Hello, everyone. All right, so for 3B, we're going to be really focusing on graphing these linear equations, and we're going to look at something that we call direct variation. So direct variation is really just an extension of graphing linear equations. So whenever we're graphing linear equations, we're going to be looking more specifically, point. We're going to be looking more specifically at slope-intercept form with a slight emphasis and whatnot on standard form. So I will say standard form and other variations of linear equations, really that's going to be for honors. So whenever we are graphing, we are mostly going to be using slope-intercept form. So one thing I want to emphasize is whenever we are graphing, you have to start with the y-intercept. This is a non-negotiable, like no exceptions, no ifs, ands, or buts, no highway options. You have to start with a y-intercept. So the reason being is because we have a starting point. We have to have a starting point somewhere. A rate only changes, or a rate or a slope or whatever is only telling us how it's changing, but it's not telling us what is changing. We have to know what is changing. So that's why we have to have a starting point, which is typically going to be our y-intercept. So when you first start graphing, so here's a few steps that you can kind of keep in the back of your head or however you want to do these. So as always, you have to start with a y-intercept. So plot your y-intercept first. So up here, we have the equation y equals x. So I'm going to rewrite this so that you can actually visualize it in slope-intercept form. So with our x value, the number in front, we don't have a number, so that's going to be a 1. So think of it, y equals mx plus b. So this is going to be y equals 1x plus 0. So this 1 here, the number in front of the x, this is your slope. Whereas the number over here, being added, subtracted, or whatever, this is your b value. So that's your y-intercept. So in this case, we have a slope of positive 1, and we're going to have a b value of 0. So this is where we have to start. So we're going to start at 0, 0. So you have to plot the y-intercept first. So 0, 0 is going to be our origin. So I'm going to put a point right here at the origin. All right, so now for step 2, now we want to apply the slope and plot at least one other point. So emphasis on at least one other point. It'd be better if you plot more than one, but just one additional point is the absolute minimum. So to apply the slope, we want to do our rise over run. So if I have a slope of 1, this is the same as doing 1 over run. So we want to rise 1 and run 1. So I want to go up 1, and then I want to go right 1. So I'm going to go up, right, up, right, up, right, up, right, up, right. So from here, I'm going to go up 1, right 1, plot another point. Then once again, up 1, right 1, and plot another point. So you just want to keep following that pattern of up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So if you notice, we're going to the top right, but if you see here, we still have a whole other half of the graph that we can use. So if you want to go the other way, you just have to do the opposite. So instead of going up 1, I want to go down 1. Instead of going right, I want to go left. So down 1, left 1. So that would be the opposite. So that will give you the other half of the graph. So now we have this entire graph that has our pattern. So what I'm going to do is I want to draw a line that connects all those points. So luckily we have technology. So I'm going to draw a line that goes through all of those points. So here's the beautiful thing about technology. So I'm going to actually let you guys see the screen here. So I'm going to use the scissor tool up here. So the scissor tool is this tool that is right here on your toolbar. So I'm going to use that scissor tool to actually tap on the line, and it's going to give you those 2 points right here. Those are adjusters. So you can actually change how you want to fix your graph. So because I had my graph right here, what I want to do is I want to actually extend it to fit my entire graph. So it works for both ends. So like if you draw your line and it's like right here, well, I want to extend it all the way through those points. So I'm not saying it has to be way over here, but you at least want to extend it through all your points. All right, so there's your line, and then you want to draw arrows at the very end to signify that it's going to go on indefinitely. Okay, so the arrows, that is step 4. All right, so moving on. So now we have y equals 3x. All right, so here, this is the same as y equals 3x plus 0. So our slope here is going to be 3, and our b value here is going to be 0. So our rise over run for our graph, this is going to be the same as up 3 and then right 1. So if it's a whole number, it's always the number on the top and then over 1 on the bottom. So you rise up, go 3, right 1. So we're going to start at the origin again. So this means we're going to be starting at 0, 0. So same as before. So plot a point. And now I want to go up 3, right 1. So 1, 2, 3, and then right 1, and then plot a point. So same idea for the next one. So 1, 2, 3, right 1, plot a point. So 1, 2, 3, right 1. So notice how I'm filling up the entire graph and every single point on the graph that I possibly can. So that's something that you want to do just so you can get a better picture and a better visual of what your graph's going to look like. So notice how if I try to keep going, I run off the graph. So that would be your indicator to stop. So once again, now you want to look the other way. So if we're going up 3, right 1, now I want to go the other way. So now I want to go down 3, 1, 2, 3, and left 1, and put a point. So same idea. So 1, 2, 3, then over 1. So 1, 2, 3, over 1. All right, so now I can't go anymore. So that's how I know I got all the points on my graph. So now I'm gonna actually really take advantage of that scissor tool. So I'm gonna show you guys what I mean. So let's say you only drew those 2 points. So this is where that scissor tool is gonna come into play. So I'm gonna draw and connect just those 2 points. That clearly is not gonna be an adequate line. So you're gonna have to draw a better line. So if you want, you can use that scissor tool to really extend and connect those 2 points. So that is the line that we want. So ideally how you know it's gonna be enough is if when you draw your arrows, some of the arrow is off the graph. That's how you know it's gonna be a good length. All right. All right, now over here, number 3. So in this case, I'm gonna do this without rewriting. So in this case, once again, we have plus 0. So our y-intercept again is 0. But my slope here is -3 over 4. So it's actually already written in the form for rise over run. So our b value is still 0. So when I say rise over run, it's a little bit different. So now we're going to go down 3 because it's negative, but we're still going to go right 4. So we take care of this negative when we go down. We never will go left unless we're trying to go the other way. So you're always going to go right. All right, so I'm going to start at 0, 0 again. So now I want to go down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. I'm going to get rid of these. So once again, go again. So 1, 2, 3, 1, 2, 3, 4. So I'm drawing these lines just so you can kind of see what exactly I'm counting. So we're counting the square spaces. So I can't go any further. So now I'm going to go the other way. I'm going to go the opposite. So now I'm going to count up 3. So 1, 2, 3, and now I'm going to go left 4. So 1, 2, 3, 4. Plot a point. So 1, 2, 3. Well, 1, 2, 3. 1, 2, 3, 4. So this is the last point that I can plot. So now I want to draw my line. So I'm going to start at this endpoint, go to the other endpoint, draw all the way through, use my scissor tool, and now extend it with arrows. All right. So now we're going to get into equations that don't have a y-intercept of 0. So now here we have a slope of 5/4 and a b value of -3. So now I want to start at 0, -3. All right, so my rise over run. So now I want to go up 5 and then right 4. Okay, so start at 0, -3. So right here. So now we have our starting point. So from here, now I can apply my rate of change, my 5/4. So I'm going to go up 5. So 1, 2, 3, 4, 5, and then right 4. 1, 2, 3, 4. So there's that point. So I'm going to apply the change again. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's just enough. All right, so I'm going to go the other way just so you can get some more practice so you can see what it looks like. So I'm going to go down 5. 1, 2, 3, 4, 5, and then left 4. 1, 2, 3, 4. So we can only go once. All right, now I'm ready to draw the line. So press and hold, draw your line, let it auto straighten out. Scissor tool, extend with arrows. All right. So for number 5, now you see how we have a y equals a number, so y equals 5. So notice how there's no variable. So this is going to be an indicator that this is going to be a Hoy-Bucks problem. So if you remember, we have a y equals, which means this is going to be Hoy. So we have a horizontal line with 0 slope, and it's a y equals equation. So our slope is going to be 0. That's from the middle term right here. We have 0 slope. Now our b value, because it's a horizontal line, remember this b value represents your y-intercept. So because it's a horizontal line, it's going to cross the y-axis, which means our y-intercept is actually going to be that number 5. So what I'm going to do to graph this is I'm going to go up to 5. So 1, 2, 3, 4, 5. So I'm going to put a point. This is my y-intercept. And I want a horizontal line that just passes through that point. So horizontal line that passes directly through that point with arrows. So that's all that one needs. All right, so now for number 6, now we have x equals 5. So I was very strategic when I did these two problems on the notes, how they look really similar, but they're actually vastly different. So this one is going to be a Bucks problem. So we have a x equals equation. So what that means is we have a vertical line with an undefined slope. So our slope here is going to be undefined. So I want to go to +5. 1, 2, 3, 4, 5. Hopefully I can count. Everything's fine. I only teach math. So it's a vertical line that passes through 5. So now look at this last question over here. We're looking for the y-intercept. But if you notice, our y-axis is way over here. So our, how dare you? How dare you? How very dare you? Can you straighten? That'd be great. Thank you. All right. So if you notice our y-axis over here, it never crosses. So what that means for your y-intercept here, it is D in E. It does not exist. For those of you that need a reminder, it does not exist. It never crosses the y-axis, so we can't have a y-intercept. All right, moving on. So same idea, but now I'm going to give you an equation in standard form. So in standard form, you have a few different options. So you can either do the converting like we did in 3a, or you can do the trick. So I'm going to do it both ways to kind of give you guys a glimpse to see what it would look like. So we have 3x plus 4y equals 12. So I'm going to convert. So I'm just going to convert this really quick. So when I say convert, remember we're solving for y. So subtract 3x. So I'm going to have 4y equals negative 3x plus 12. Remember, we put the x in the front to resemble slope-intercept form. So 4, I'm going to divide. So I have y equals negative 3/4 x plus 12 divided by 4, which gives you 3. So in this case, we have a slope of negative 3/4, which is our m. That's a terrible m, but you get the idea. And we have a b value of 3. That's not a b. That's a b. Everything's fine. So we have negative 3/4, which is our slope, and a b value, which is 3. All right, so now I'm going to actually do the standard form trick. So if you remember, so your slope is the opposite of a over b. So your x-intercept, which you don't necessarily need, but I think it would just be good practice to keep practicing and getting. And then your y-intercept, which is c over, how dare you, c over b. All right. So now I'm going to go up here and I'm going to identify my a, b, and c values before I do this. So my a value is in front of the x, which is 3. I promise that's a 3. There we go. Our b value, which is 4, with a c value of 12. All right. So the opposite of a over b. So I'm going to take my a value, which is 3. I'm going to negate it. So that gives you negative 3. So negative 3 over 4, which matches, so we're good. Now I want c over a. So this is our x-intercept. So we don't necessarily need this value, but like I said, it's still good practice to find. So c over a, which is 12 over 3, which is 4, which as a coordinate is 4, 0. And then for our y-intercept, now we have 12, let's say it was 4. Yes, 12 over 4. Why is my handwriting so terrible? I am so sorry. 12 over 4, which is 3, which is 0, 3. So you're gonna, so once again, those match. So you want to start with your y-intercept. So 0, 3. If you haven't figured it out yet, I really like purple. It's my favorite color. All right, so now I'm gonna go down 3, right 4. So down 3, 1, 2, 3, and right 4. 1, 2, 3, 4. So if you notice, that also matches our x-intercept. So you could even plot the two intercepts and then draw a line between those two intercepts if you want. So 1, 2, 3, 1, 2, 3, 4. All right, so I have 3 points, which is more than enough to draw a line. All right, then scissor tool, I'm going to extend on this side and then include my arrows. All right, so there's that line. Okay, now for number 8. So now they're just giving us this pain and suffering. So you actually have to simplify it and put it in slope-intercept form first. So the first thing is you got to distribute. So I'm going to have y equals 2x minus 8 plus 5. Don't forget to distribute to both terms. All right, so now I'm going to combine my like terms. So negative 8 and positive 5 can combine to give you 2x minus 3. So in this case, your slope is going to be 2. and a b value is -3. So start at -3 on your y-axis, and then apply a slope of +2. So that means you're going to go up 2 and right 1. So 1, 2 over 1. So 1, 2 over 1. So 1, 2 over 1, 1, 2 over 1. All right, so that'll be enough points. Same. Oh, yep, no, come back. All right, so scissor tool to extend the line. Oh, no. No. Close enough. There we go. All right, so there's our equation. All right, so now we're going to get into a more specific type of graphing and type of equation, which is what we call a direct variation. That equation? That was my vertical line. So for your direct variation, it is simply a linear equation that passes through the origin. So meaning it's going to have a b value of 0. So if you notice up here, like our first equation up here, does it pass through the origin? Yes, that is a direct variation. Our equation here, does it pass through the origin? Yes, that is a direct variation. Our equation here, pass through the origin, it's a direct variation. Our equation does not pass through the origin here, so this one is not a direct variation. So for it to be a direct variation, it just has to pass through the origin. So our b value just has to be 0. So if you notice here, both our horizontal and our vertical line, neither of them pass through the origin, so neither of these would be classified as a direct variation either. And neither would those. So we're going to be looking at these equations in their written form and determining if it is going to be a direct variation. So in this case up here, we have y equals 3x, which means there's a b value of 0, which is what we want. We want the b value to be 0. So what that means is, yes, this is a direct variation. Number 2. So we have a b value of 2. So this is not equal to 0, which means this is no bueno. So this is not a direct variation. Number 3, we have y equals -1/2 x. It's plus 0, which is what we want. So this is a direct variation. And then over here, number 4, we have a b value of -1, which means it's not 0, which means this is not a direct variation equation. So remember, it just has to have a b value of 0. It has to pass through the origin. So we're doing the exact same thing that we've been doing. We're just adding like a slight extra step to it. All right, so now we have y equals 3x. So I want to determine if this is going to be a direct variation. So over here, we have y equals 3x plus 0. So our slope here is 3 with a b value of 0. So in this case, because our b value is equal to 0, that means, yes, it is going to be a direct variation. So I don't even have to graph it to know that it's going to be a direct variation. So I'm going to start at 0, apply my slope of 3, which means up 3, right 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. All right, so that's all I need for my graph. So I'm going to extend with arrows. Boom, done. Number 6. All right, so in this case, we have y equals -3/2 x. Our b value over here would be 0 because there's not 1. So we have an m value of -3/2, b value of 0. So is this a direct variation? Absolutely, because our b value is 0. So I will abbreviate direct variation as dv just because I'm a math person, because I'm lazy. So I'd rather type out dv or write out dv, so it's easier. All right, so in this case, start at 0. So down 3, 1, 2, 3, and then over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right, so just to get some more practice going the other way, remember, instead of going down 3, now we want to go up 3. So 1, 2, 3, and we want to go the left side, which I'm pretty sure that might be backwards for y'all. 1, 2. 1, 2, 3. 1, 2. So 1, 2, 3. 1, 2. Oh no, come back. Okay. I'm going to draw my line. And extend. Oh no. Arrows. Boom. Throw a little bit more color in there. Okay. So number 7, now we have f of x equals 2x minus 5. So if you remember, function notation is going to haunt us forever. So this is the exact same as y equals 2x minus 5. All right, so our slope here is 2. B values, that's a weird 5. Negative 5. So because our b value is not 0, this is not going to be a direct variation. So down here, so I'm going to start at negative 5. And now we have a slope of 2. So up 2, 1, 2, and right 1. Up 2, right 1. Should probably put a point. All right, so I'm going to actually do a couple, I'm going to do a couple points going the other way. So down 2, down, I can't count. Down 2, and left 1. Everything is fine. Let's do orange. All right, so press and hold. Draw your line. Hello. That's not a line. Press and hold. There's your equation. Scissor tool. Extend. Boom. Boom. All right, number 8. So referencing the previous problem, f of x, this is the same as y. So if you notice, there's literally no other variable, constant, coefficient. There's nothing on the right side except for that 4. So what does that mean? It means it's a Hoy-Bucks problem. So now ask yourself, is this going to be Hoy or Bucks? Well, we have a y equals, which means it's going to be a Hoy. Hoy. All right. So we want a y value of 4. So I'm going to go 1, 2, 3, count up. A y value of 4. So if you remember, the h here means it's a horizontal line. So I'm literally just going to draw a horizontal line through that point. That is a terrible arrow. All right. So if you remember, the middle value in Hoy means 0 slope. So we have a slope of 0. And our b value, our y-intercept here, is at 4. So is this a direct variation? Does it pass through the origin? Absolutely not. All right. So now we have a couple little, not really word problems. These are more like application kind of. So we have what we call a direct variation equation. So on the note key, I wrote y equals mx. So silly old me. This is actually supposed to be y equals kx. It's the same idea. It all represents the same thing. It's just a different letter. So this is what we call a direct variation equation. It resembles really closely to y equals mx plus b, but remember, for a direct variation, your b value is 0. So what we're doing here is, given that y varies directly with x, write a direct variation equation that relates x and y. Find y when x is equal to 4 and find x when y is equal to 6. So over here, I have my equation y equals kx. So k, we're going to pretend that's a k. So k is what we call the constant of variation. It's our COV. So it's literally the same as slope. There's 28,000 million names for slope. Constant of variation is one of them. Rate of change is another. So we're essentially looking for a constant of variation. So they're telling us that our x value is 5 and our y value is 10. So I'm going to plug those in. So I'm going to have 10 equals k times 5. Now I want to solve for k. So what this means is I'm going to divide both sides by 5. So that means 2 is k. So now I'm going to take this k value, and this is what's going to get plugged into my equation up here. So my equation is y equals 2x. So that's my direct variation equation right here. So this is part of the problem that I want to find. So now I want to find y when x is equal to 4. So find y. So I'm actually going to do this in 2 columns. So you can do this however you please. So find y when x is equal to 4. So y equals 2 times 4. And find x when y is equal to 6. So I want to solve both of those equations for their respective variable. So y equals 2 times 4, which is 8. And on this side, I'm going to divide by 2. So x is 3. So they're single step equations. So they're not terrible. They're just inconvenient. This is going to bother me. K is the constant of variation. There we go. Okay. So same idea over here. I will say some of these will be fractions and they're going to be gross and terrible. So I'm going to start with y equals kx. So I'm going to start by finding my equation. So I'm going to have 8 equals k times 12. Speaking of fractions, here we go. Divide both sides by 12. So k is 8 over 12. Divide both by 4, and you get 2/3. So our equation here is going to be y equals, that's a 3, 2/3 x. All right, so now I'm going to do my 2 columns again. Why can I not draw a 3? All right, so find y when x is equal to 4. So y equals 2/3 times 4. And then over here, your y value is equal to 6, so find x. Hello, that is a variable. I do not need parentheses. All right. So over here on the left side, I'm going to multiply the 2 and the 4. So that gives me 8/3. Then over here, I'm going to multiply by 3/2. So I'm going to do 3 times 6, which is 18, then divide by 2, so that's 9. So we have the equation, the y value, and the x value. So I'm going to highlight those. All right, I would definitely say try this one on your own. All right, so we're going to have -9 equals k times 15. I'm going to divide by 15. So k is equal to -9 over 15, which simplifies to -3 over 5. Wow, this is truly horrible. Okay. So y equals -3/5 x. Y equals -3/5 x. So our equation is y equals -3/5 x. So as before, find y when x is equal to 4. And find x when it's equal to 6. All right, so on the left side, so I'm going to multiply -3 times 4. So this is going to be y equals -12 over 5. Then over here, I'm going to multiply by the reciprocal, the opposite reciprocal, actually. Okay, let's move this over here so we can actually see it better. So So I'm going to multiply negative 5 times 6, which gives me negative 30 over 3. Then you divide, you can simplify, so x is negative 10. So those are the three values that we're looking for, the equation and the two corresponding values.